So thank you for joining me to the introduction to the RIST Relay, the use cases that one may use in order to develop a better application using the RIST Relay. I'm Adi Rosenberg. I'm the CTO and co-founder of Alvalinks. And special thanks goes to Ciro Neronia from Cobalt, who is also with us, for assisting me in making this presentation a reality. So let's start. So introduction about myself. I'm Adi Rosenberg. I'm the founder of Alvalinks. Alvalinks is designing video delivery intelligence. Whoever wants more information, you can use this link to see an IP Showcase presentation about what we are doing. I'm a member of the RIST activity group since 2017. I'm also a RIST forum director for many years. I wrote some of the patents that are the basis for the RIST simple profile and the main profile specifications. So what is the motivation to develop a RIST relay? What made us work and spend so much time? We wanted to tackle some of the problems that users had and field feedback, and we wanted to solve some of the problems, and let's see them one by one. First, we wanted to connect peers behind the firewall without the need to open ports in advance. With simple profile, main profile, even advanced profile, you may need to open one port in your firewall to the server so that a peer will be able to connect. We wanted to overcome that requirement, just like other protocols do today. We wanted to simplify the connection of peers with unknown IP location to each other, so that you don't need to know exactly what is the IP of the peer, and you still will be able to connect, as long as you know its name or a nickname that somebody assigned to it. We wanted a SIP-like mechanism to connect peers and organizations alike. We wanted to create a proxy to organizations to minimize their exposure, meaning that instead of opening many ports and many machines, we wanted to do something outside the organization that will connect securely to one port to the organization for allowing traffic in and out of the organization through an external proxy device. And that is the RIST relay. Now, we also wanted that entity to pipe traffic between peers or even a group, meaning that I can send the traffic to one peer, or I can send it to a group, and so that a relay will propagate that traffic to many group members. So it becomes a distribution very similar to a multicast. Distribution of content, the idea was to distribute content to multiple locations. Also, because it might become a choke point, have a selective backup option. We also wanted to have protocol conversion, meaning that nowadays RIST advanced profile has many protocol or encryption capabilities, PSK, DTLS, even WireGuard. We wanted the abilities so that a mobile phone that has a WireGuard will be able to connect to organizations that support PSK without needing to support all the encryption modes. Somebody will do the translation for it. And we wanted a single point for the system-wide security authentication to take care of everything without multiple entities doing all of that on a daily basis. So the big question starts with, well, you guys are experts. Why didn't you go to what the industry is used to do? We have the stun, the turn, and the ice. And that was a very big question that we had to tackle and answer by ourselves. So the RRFCs that provide these functionalities, ice aided by stun and turn, what's wrong with that? And the answer that we came is that it's not sufficient for what we want to achieve. They are not complete solution to comply with what we came in the previous slide. Stun allows clients to figure out its public IP. So I, as a peer, will know my public IP. Great, what can I do with that? Turn will relay traffic between, in cases where a peer cannot connect to a peer directly. which is great. ICE is a means to negotiate start and turn. So once again, doesn't solve the problem. You still need another package to do everything, to discover the peers, have address books, and so on. So there are problems. And also, we also saw a wide report that start and turn have possible security issues that we didn't want to tackle. So we thought around and we said, wait a second, we have the amazing advanced profile, the RIST advanced profile, which is a higher security capabilities. And let's connect the good things about start, turn, and ICE into one entity. That we will call it a RIST relay. So we elected to use the same security for the advanced profile into one new functionality. And we are here to explain what we are going to do, what you can do with that, and what are its merit. So what do we want to have? So basically, we want to have an external server somewhere in the cloud. And this is the RIST relay. This is a server in the cloud. And we have two peers. And in this example, they both are behind firewalls. And we need to connect them. We need to find a way to connect those two peers. So how do we go about doing that? We want to traverse firewall. Now I have to stop here and say there are two kinds of firewalls. There is symmetric and asymmetric, and I'm not going to go into that, but some firewalls will allow outgoing traffic to come back to a different port, but others will not allow, the traffic must come back exactly at the same port, exactly with the same IP that the client, that the customer or peer elected to use. So that restricts the capabilities. We wanted to overcome that. So what we are doing here, we have our RIST relay, and we basically tell each peer to connect, to establish communication with the RIST relay. Once they do that, they can say, I want to talk to my other peer, I want to communicate with him, or there might be a list in the RIST relay that says, these two peers should communicate. So then when we create a stream, a tunnel, whatever, it goes through the RIST relay. So now the RIST relay pipes the traffic through on any direction. So those, we overcome the firewall limitation. So we have a secure, authenticated, and fast connection with a minimum delay between the two peers. So we overcame the problem. Hey, what's bad with that? So next was the question of what do we do with the ARQ? And we said, let's have two options. One is that just like other solutions out there, a RIST relay will do ARQ termination, meaning that it will be able to recover lost packets on the path from the peer to it and from it to the other device. So in this case, the RIST receiver, the RR, which is the RIST relay, provides reception buffer to the sending clients. So there is a buffer, it does the jittering, it does error recovery, and the client interacts with the RIST relay to recover any packet on the path from the peer to the RIST relay. And the same goes to the other party. So RIST relay will act as a repeater to the receiving client. So the ARQ protection is on a pair link basis, and it allows links to optimize individually for buffering and how many retries you want to do per peer. So, hey, that's a great idea. But then we thought, well, why do we have to do that? Maybe we can allow RIST relay to be much more nimble. And we said, why not to allow transparent ARQ, meaning that we will allow each client can do its own ARQ. So basically the RIST relay will allow the ARQ to flow from A to B through the relay without any buffering and be done with that. So it's basically, there is zero added buffering, and the ARQ is done end to end. It's another option that the RIST relay can support if asked to do so. So that's basically an idea that there's no intermediate buffering, and you can build systems that utilize end-to-end ARQ, or you can have a middle point that does the ARQ. It's up to you to decide how do you do that. Now, why can't we do a relay bypass? What is a relay bypass? Just like with WebRTC, to those who knows WebRTC, you can go to a connect to a meet point, but then bypass that and communicate directly. So we allow the RIST Relay to support that capability if the devices are able to support that. So each client will try, basically with what we'll do, it will connect as before to the RIST Relay. And if it's capable of doing bypass, the RIST Relay will pass the security information, because we need to establish a tunnel, to both ends. And then they will be able to stream directly, and effectively bypassing the RIST Relay, communicating directly through the firewall to each other without the need of the RIST Relay. The RIST Relay acts just like an initiation server for the establishment of the connection, and the two devices can communicate. Next, there was a requirement that let's get rid of the IPs. Let's use nicknames. Let's have an address book like SIP and Skype. I want to call my friend. I know his name. So if there's an address book, I will basically use a nickname for communication. Instead of saying IPD A, B, and C, I will say reporter 1, 2, and 3. So a RIST Relay will maintain an address book of all clients that might connect to it. You can create the address book will be distributed with all clients connecting, so that they will know who are the clients that they might be able to communicate with, just like you have with your Skype account. You also will have information about the client availability, if it is connected or not, which is another idea. So you know that the resource is there and you can communicate, start negotiation and communication. And the RIST Relay assigns a name to each client and adds deleted from the address book. So each client can download the address book and the name of possible clients it may interact with. Now, a client may be a member of one or more call groups, just like with Skype, meaning that you can create just a reporters group, sub-organizations, whatever you want. And once you have a group, you can communicate with the entire group or send or receive content that is distributed within the group. So that's another functionality that was not there before, and it is not available in any other protocol out there. So that's it. Now, a client may ask to be connected to another client or a group once that client is available and connected to the RIST Relay. So then you see that they are connected, you see the group is active, you see members are there, you can then say, I want to connect to them and I want to start sending or receiving from them. Now, we said, let's do some more smart thinking and maybe somebody will build applications. Why to limit ourselves to only one link, to only one tunnel? If I have the option of having multiple mediums, multiple service providers, like in this case 5G, 4G, and 1, I am able to connect to the RIST Relay by multiple tunnels and then use that to connect to my peer or vice versa. So then the client might use that using the same name, and he can send the data over 1, 2, 3, or use Loacher, which is a capability that is inherent in the advanced profile. So then he has a better functionality. So if one goes down, he still has a connection. It is exactly the same name. The RIST Relay will maintain a list of active links that they can be connected with. So then communication is much better than maintaining multiple tunnels when needed. So it's another advantage of the RIST Relay. Next, there was a problem that we we tackled and solved is that a RIST relay may be considered like a choke point, single point of failure. So let's consider that this environment, we have multiple peers connecting over main RIST relay. We can have a backup with the same configuration. And then if the RIST relay dies, basically the clients can connect to a backup server and continue the communication. A RIST relay also have the capability to say, you know what, I'm too busy, I'm overstretched. If you want to connect to your peer, go to that backup server to do the connection if it's available. So it gives you an alternative to continue your business if needed. Now, let's think about application use cases. I have an organization, let's call them ABC, just as a CBA, just an acronym. And I don't want to expose, as I said, too many ports because it's a security hassle for me. The IT teams will need to open ports upon ports. With the RIST relay, I can put the RIST relay outside my organization in the cloud whenever I need that, open a single tunnel, it's an outgoing connection, so I even don't need to open any port in my firewall to establish a tunnel to the RIST relay. Now, to this RIST relay, I am able to connect and send and receive traffic through multiple clients, organizations that use the RIST relay to reach me securely without any hassle and any problem to the IT group. All the IT group need to fulfill is to have enough bandwidth to support the use case. So it's a security enhancement. Everything is over-secured. You have the certification, you have the authentication against the RIST relay, so I secure, and you can pass any security inspection when needed. Now I want to do a distribution. Let's use another use case. I have the organization and I want to distribute content to a multitude of clients. Instead of sending one by one as a way of a unicast, what I'm doing is sending my feed to the RIST relay. I am saying that the peers are a group, so the RIST relay will forward the traffic for me to that group. The RIST relay pushes the traffic to a group of clients for distribution application. Error recovery, we covered that, can be set between the client to the RIST relay, but also RIST relay will handle the ARQ recovery and buffering for the clients. Easy breezy, great application and use case. Let's talk about security. Every endpoint must establish a RIST advanced profile connection. A RIST advanced profile connection means it comes with encryption and authentication. That's a mandatory stipulation, otherwise enterprise will not use you. So that's every encryption option in the advanced profile is covered. You can use DTLS. You can use DTLS with TLS SRP by way of using username and password for authentication. You can use PSK with EPIP SAH 256 SRP. Once again, username, password authentication. And you have WireGuard, which was added in TR06 4 Part 2, which also has a certificate file. The authentication information identifies each endpoint to the RR. So the RR is the one responsible of generating all the certificates to all the peers that wants to connect. So it's one place that you can create that. And when it's outside the organization, you can use the CA organization to validate certificates if needed, if you want extra security. Endpoints, what we added is are identified by a human readable name, similar to Skype. This is something that we think is a better use case to give a humanly readable name, reporter 1, reporter 2, BBC Ireland, BBC Johannesburg, BBC Australia. Something that is much more usable, definable, so it's easier to identify the cost of the peer on the other side. The RIST relay may say no to a peer. Why it will say no? It can deny requests based on security policies because the certificate expired, or maybe somebody else is already using the certificate for some reason. So then there's a duplication, so it can block another attempt to connect. Let's see another use case for the encryption. Basically, this is the conversion. Basically, the RIST relay can convert from DTLS to DTLS, DTLS to PSK, WireGuard. Basically, the RIST relay can communicate with any fashion, so it basically acts like a bubble fish between clients to overcome encryption and authentication used by each client. So the conclusions are, the RIST relay will simplify the connection of clients behind firewalls. It will enable new cloud and internet applications to rise. It's a robust solution that can be designed to utilize RIST relay. Robust solution will be able to utilize RIST relay proxy, transparent distribution, and backup capabilities for their new applications. It is very IT friendly. And any more questions? Let's do some questions. And if you want more in-depth information, there is a YouTube that you can dive into the bits. It's a presentation done by Cyril Neronia. And there's also discussions about applications, ideas, something that was done in the RIST Activity Group panel at VTrans 2022.
Thank you.
Hold on, last one thing. The RIST relay specification should be available in the coming weeks in the VSF TV website. I'm done.
That's great. That's great. I was just gonna thank you so much for putting this together. And I was gonna see if anyone in the audience has any questions. You can speak up or you can put on the chat. One question here that we got earlier was, why do you need the relay versus the standard RIST server?
Good question. It boils down to security. With the RIST server, with the standard RIST server that we know from the main profile, the advanced profile, you still need to have an open port in order to reach that, an open port in your firewall to reach the server. And the server basically creates a one connection. A RIST relay is more than that. It doesn't need to open any port. That's number one. Number two, it gives you more functionality. It gives you the capability to connect peers when you need to do so. Yes, it adds some delay, but if you need to go from point A to B and and point A and B are moving targets, meaning that there may be mobile phones or the IP is not known, the use of RIST relay will connect them time after time, even and when they pass IP domains. So when you pass an IP domain, meaning that you go to another subnet, you just reconnect to the RIST relay and the connection will continue from that point on. You can have multiple connections, so then when you move, it would just jump between connections. So it gives you much more capabilities and to continue the service and establish the service when needed, as needed.
Mm-hmm. That's great. Thank you. What is the added delay of the relay?
Ooh. Well, right now we don't have solutions right now to talk about, but let's say we spoke about two options. One is with a buffer, one without. Without a buffer, the added delay will be the latency, the RTT between peer A to the relay to the other peer. So we will have to add that. So, and I assume that the RIST relay will add less than 1 millisecond to take in the packet, authenticate it, and pipe it to the other end. So it's like 1 millisecond delay, which is almost nothing. When we have buffers, so assuming that they're using the 500 milliseconds buffer, then the added delay would be about 500 milliseconds of the RIST relay for the incoming traffic. The outgoing, you don't have another buffer. So the added delay would be 500 plus 1 millisecond or so.
Mm-hmm. So it depends. And in terms of the certificates, who creates the certificates?
Good one. So the certificates are created by the RIST relay itself. The vision is that the operator, the implementer of the RIST relay will be the one creating the certificates, assigning user names and distributing those certificates to the peers that are eligible to connect to the RIST relay.
And how many peers can a relay support?
Wow. That is basically compute. There should be practically no limitation. The only limitation is NIC capacity and the processing capacity. So if we are imagining cloud-based application on AWS, Google, it can be thousands of peers, and the only limitation is the NIC capacity, the traffic capacity of the instance running the RIST relay. So if it's limited by 4 gigs, 440 gigs, that is the only thing limiting the capacity of traffic.
So do you see the RIST relay as a viable alternative for distributing live content to like end users?
Why not? Other than the market acceptance, I don't see why not. If a RIST relay, if we want to achieve, just thinking out loud, if we can have RIST relay distributed near the consumer, it basically becomes very similar to a multicast. And just like a multicast or an IPTV applications, where the peer would connect to a rendezvous point, in this case, the peer will connect to a RIST relay that already has incoming traffic from the source. That traffic can be distributed with error recovery to the peer, so it can reach a mobile device, a TV that's running a RIST application. I hope that somebody will check that kind of application. It does sound viable. And low delay in that sense.
Yeah, that's the holy grail, right? For sports and the definition, you want the delay to be as low as possible.
If we will tie that to the adaptivity nature of the RIST, or to create profiles like MABR, so that the client can jump between profiles, those would be streams, that should be achievable, I believe.
Mm-hmm. And we got a question here: to replace WebRTC. Can that be?
We didn't think about replacing WebRTC. We tried to borrow some of the functionalities that are available in WebRTC. There might be enterprise-grade applications that you need true low delay and high quality that it might be useful for. The biggest problem is to have an application that can run a similar RIST application to WebRTC client. I know that there are work being done in the RIST activity group to see how RIST can be implemented within the WebRTC. If something that will come to maturity, I will definitely have a better answer for you.
Yeah, it sounds like this company is thinking about that. So, so I guess we can keep in touch with them, and we can help them further.
The idea is that some folks that, without naming names, folks that are on this call, they might use the RIST relay as a POP in like building multiple POPs on the cloud, so that a RIST relay will propagate traffic between endpoints. That's an idea that you can do to propagate traffic through with protection and so on.
Well, separators was saying that what you just explained is just how they utilize RIST within their monitoring distribution ecosystem already. So that's how they use it.
I think there are more questions in the chat.
Any more questions?
While we wait for more questions, I would like to comment the fact that the TR came out of the AG, was approved out of the AG last week, and is now being sent to the VSF board of directors for final approval. So when Adi says should be available in the VSF.tv website, that's imminent. It's either maybe this week, maybe next week, this is going to be published.
Yeah, so that's great. If no one has any further questions, this is also going to be published on the RIST YouTube channel in the next couple of days. So the session will be there. I'll send the link to everyone, all the members and all the people in our database. So everyone who couldn't come to the session live can have access to it. And thank you so much for attending. And thank you very much, Adi, for putting this together with Ciro's help. Thank you, Ciro. And you guys
That's
are
all him.
You guys are fabulous.
Enough.
Great set of slides. So no more questions?
Guys, tough questions. Come on. We still have time. Nothing. Okay.
Okay.
Oh, there is something.
Okay, there's somebody put something here. Oh, thank you. Yeah, he's thanking you.
Yeah. One thing I wanted to make sure people understand, we created this protocol in the AG, but that allows you, if you're in the business, that allows you multiple business opportunities, right? You can make products and sell products. You can make service. So I love to see someone to provide a commercial RIST relay service. So you just pay them some money and you connect to it. So there's opportunities here.
Yes, that was something that the customer members of the RIST activity group says, we would love to have something like that because it solves a lot of our problems in the security aspect, not bothering the IT folks, the time to spin up stuff. If it can be run, hosted on a cloud service, it will be a great opportunity for us to use. And the business model, you can decide what you want to do and what is the capability. It is something that is definitely adding more functionality and will spring more applications as we go along with that.
Yes.
Yes, always innovating, always ahead. That's amazing. Thank you so much. Thank you, everyone. Have a wonderful rest of your day. And again, we'll see this again on YouTube.
Thank you,
guys. Thank you.